Miss Atiqah here. Welcome back to my class. I hope everyone is doing well. So our focus for today is subtopic 2.7 on impulse and impulsive force, discussed in chapter 2 of Form 4 KSM Physics titled Force and Motion 1. Before we delve into our lesson, let's review the learning objective for today's class. By the end of study, students should be proficient in explaining impulse and impulsive force as well as solving related problems. But first, let's enjoy a quick video on a real-life example connected to our topic today. Ready? Let's get started.
Big wave in emotion, like how a single word can make a heart open. I might only have one match, but I can make an explosion. And all those things I didn't say were wrecking balls inside my brain. I'll scream aloud tonight. Can you hear my voice?
Alright students, quick question about the video you just watched. Have you ever thought about why the long jump athlete's leg bend before landing? There are a cool physics concept behind it called impulsive force or impulse. Want to unravel the mystery a bit more? Let's go. Alright, let's dive in. Impulse refers to the change in momentum caused by a force acting on an object over a period of time. It allows you to calculate either the change in momentum or the average impact force during a collision. The formula for impulse is J equal to delta mv, which is change in momentum. Now, let's walk through an example to better understanding in solving impulse question.
Alright students, so let's take a look at this example. First of all, we have to gather all the information that given. And one of it is, it said that initial speed is 12 meters per second. So we have to write E is equal to 12 meters per second. And it also say without altering its initial speed. So the final velocity is 12 meters per second also. But it was negative because in the question it says that batsman cannot bat a ball, so it's negative. And then we have mass is equal to 0.15 kilogram. So with this information we put inside the formula. J, which is impulse, is equal to NV minus ME. So we can simplify, write it like this: negative 12 minus negative 12 meter per second. So we have to calculate this and then we get negative 3.6 Newton. That's all.
Now, let's shift our focus to impulsive force. Impulsive force is characterized as a substantial force acting over a brief duration during a collision or explosion. It's also recognized as the rate of change of momentum. This idea of impulsive force aligns with Newton's third law of motion, formulated by Isaac Newton. Before delving into Newton's third law, let's explore how to solve problems using the impulsive force formula.
Alright, for this question, let's start. First of all, we have to collect all the data given. So the mass is 45 kg. And then the final velocity is 40 meters per second. The times is given 3 seconds. So the U is 0 m per second because it at rest. The ball is still at rest for the U. So they want F equal to. So use the formula F is equal to m v minus u. So mass is 45 kg. V is 40 minus 0 m of s over 3 seconds. So is 1800 over 3 equal to 600, and so that's how we calculate for this.
According to Newton's third law of motion, each action prompts an equal and opposite reaction. This implies that in any interaction, two forces come into play, with the magnitude of the force on the first object matching that on the second object. Additionally, the force on the first object acts in the opposite direction to the force on the second object. Now, let's explore further with another video. So class, what observation did you make from the video? The video highlights the influence of follow-through action on the magnitude of impulse. Our aim is to maximize impulse through the subsequent action. Consider a football player kicking the ball and extending their thigh to follow through, effectively prolonging the contact with the ball. This extension of time leads to a greater force exerted and consequently an increase in velocity. This reinforces the idea that a forceful kick generates a substantial impulse, resulting in a significant change in momentum and the ball traveling at a higher velocity. Decreasing the impact time can enhance impulsive force, as illustrated when a heavy hammer strikes a nail. This rapid interaction induces a significant change in momentum within a short period. The resultant impulsive force acting on the nail head is substantial, swiftly propelling the nail into its target. Let's consider another example. When a goalkeeper kicks a football, their leg makes brief contact with the ball. This brief interaction significantly increases the rate of change of momentum, resulting in a substantial impulsive force acting on the ball. This considerable force enables the ball to travel a considerable distance, and skilled goalkeeper can even send the ball close to the opposing goal on the far side of the field. And lastly, when a vessel descends with a specific momentum, the solid surface of the mortar swiftly brings the passer to a stop. This results in a significant impulsive force that passes through the chilies, effectively crushing them. Now, let's consider a scenario where the impact time is prolonged to decrease the impulsive force. The first one is when athlete land in the sandpit, the duration of impact is extended. This serves to diminish the impulsive force acting on the athletes, minimizing the risk of injuries. Next, in high jump, thick, soft mattress are used to make the landing time longer and reduce the force on the athletes. Let's look at the safety features of the car, such as collapsible steering wheels, automatic airbags, sturdy steel struts, and crumple zone. If there is a collision, the crumple zone located in the trunk and hood collapse to extend the collision time and lessen the force on the vehicle. The automatic airbag activates, ensuring the driver slows down before hitting it, reducing the risk of injuries. Strong steel struts prevent front and rear impact from reaching the passenger area, providing protection inside collisions. Lastly, soft collapsible steering wheels help minimize the impact on the driver's head during a crash and prolong the collision time. To sum up our lesson, we have covered impulse, which is a change in momentum, and impulsive force, which is the rapid change of momentum during a collision. This concept aligns with Newton's law of motion, that stating that every action has an equal and opposite reaction. For the real life example include is hammer and nail, football kicking, mortar and pestle, long jump, and also high jump. Throughout the lesson, we have emphasized the moral value of responsibility. It's crucial to ensure the vehicle function effectively to prevent several injuries to the driver and also to other driver in case of an accident. I trust that each of you can now effectively articulate explanation for both impulse and impulsive force, as well as proficiently solve problems related to this concept. So with that, I concluded my class for today. Thank you, and I am looking forward to our next class together. Bye everyone. See you.